Welcome back to the deep dive. I want to start today with a scenario that I think basically everyone listening has gone through, probably in the last day or two.
Oh, I think I know where you're going with this.
Right. You're at your computer, you pull up your favorite AI chatbot, whichever one you use,
The big ones, yeah.
and you ask it something. Maybe it's super technical, like, how do I fix this specific race condition in my Python thread pool? Or, I don't know, something simple like, who was the vice president of Bolivia in 1982?
And the response just flies back.
Yeah.
Instantly. The cursor just races across the screen, and the tone, it it's just so authoritative. It sounds like the smartest person in the room is whispering the answer directly to you.
Exactly. It feels so finished. It feels complete. And so you trust it. I mean, why wouldn't you? It sounds so incredibly sure of itself.
Hmm.
But then, you copy that code, you drop that fact into a report, and
Yeah.
it's a disaster. The code doesn't even compile. The fact turns out to be a complete fabrication. It just hallucinated.
And the really scary part isn't that it was wrong. It's that it was wrong with the absolute, unshakable confidence of a tenured professor giving a lecture.
That's it. That's the feeling.
And that is the central paradox of where we are with AI right now. We have built these systems that are just optimized for output. They're optimized for fluency, for sounding human, for seeming finished.
Right.
But in chasing that polish, we've effectively trained them to just mask their own uncertainty. They literally don't know how to say, "I'm not sure," or let me check on that. They're just eager to please, even if it means they have to lie.
And that specific feeling, that frustration of being confidently lied to by a machine, that's really the jumping off point for today's deep dive. We're looking at a document, a framework that proposes a completely different way of doing this.
A radically different way.
It's a canonical development and cognition framework, and it's called Alita.
Alita. And the subtitle of the document, it just says it all, the unfinished intelligence.
That phrase just stuck with me immediately, the unfinished intelligence. It sounds less like a tech spec and more like a philosophy title or, a sci-fi novel.
It does. But this is a deeply rigorous technical framework. The source material is dense, for sure, but it's all grounded in this one very simple but very powerful idea.
Which starts with a question.
Yeah, the authors pose this question right at the beginning. They say, look, the question isn't how do we make AI smarter? The real question is, why do our AI systems behave as if they already know everything?
Wow, okay, that hits hard. That really challenges the entire industry standard right now.
It does, because the Alita framework is built on the complete opposite premise of, say, a large language model.
Mm.
She's designed from the ground up as an entity that is still in formation.
So she's a work in progress by design.
Exactly. From the very first line of her code, she possesses limited knowledge, she has limited certainty, and this is the absolute key. She has an explicit, built-in awareness of what she doesn't know.
So the whole goal isn't to build this conversational oracle that's read the internet and just pretends to remember all things. The goal is to build, well, what do they call her? The document describes her as a long-term coworker.
A coworker. And just think about the difference in those two words for a second. A tool versus a coworker. A tool, like a calculator, is static.
Yeah.
It does exactly what you tell it, instantly.
Right.
A coworker, on the other hand, has agency. A coworker has a learning curve. A coworker lives inside the same ecosystem as you. In this case, we're talking software studios, creative tools like Blender,
Yeah.
code bases.
And a good coworker sometimes has to turn to you and say, hey, I don't actually know how to do that yet. Give me an hour to figure it out.
That's the model. That's the entire premise.
That ability to just pause, to say, I don't know, it's so central to Alita. We have a huge stack of notes here to get through. We're going to unpack her psychology, which the docs call the 5-year-old model.
Which is not a metaphor, as we'll see.
Right. We also need to talk about her studio competence, which is this fascinating idea of why she works inside 3D tools like Blender and Unreal Engine, not just in a text editor.
That whole section is incredible. It really changes how you think about what AI vision could even mean. It's not just about recognizing cats in photos. It's about reading a user interface.
And we absolutely have to get to the course mode, which is how she learns, and then
Right.
the really wild part, the terrifying yet brilliant protocols for how she repairs her own code.
The self-repair section.
Yeah.
Yeah. That's in part 5 of the docs. It's one of the most rigorous and, frankly, kind of scary parts of the whole framework.
Yeah.
It gets right into the existential risk of an AI rewriting its own brain.
Okay, so let's start at the beginning. At the core, the philosophy, the document says, and I'm quoting here, the choice to ground Alita in the cognitive model of a 5-year-old child is not a metaphor. It is an architectural decision.
And this is so crucial to get. When they say 5-year-old, they do not mean she speaks in baby talk
Yeah.
or tries to be cute.
Right, it's not a personality skin.
Not at all. They're talking about the structural approach to how she interacts with the world. I mean, think about an actual 5-year-old. How do they navigate a room they've never been in before?
They explore, they poke things, they see what happens.
Exactly. Cause and effect. They dare to try things without any guarantee of success. They learn through repetition. And, maybe most importantly, they build their confidence gradually.
A kid doesn't just wake up one day knowing how to tie their shoes perfectly.
No. They try, they fail, they get frustrated, they adjust, they try again. Alita's architecture is designed to follow that same exact pattern.
So she isn't growing towards omniscience, knowing everything all at once. She's growing toward, what was the word they used? Maturity.
Maturity, or another word they use is reliability. The framework is very clear that she operates within clearly defined limits.
Okay.
So just like you wouldn't let a 5-year-old operate a gas stove without supervision, Alita has autonomy, but it's bounded. Things like self-diagnostics or deleting a bunch of files, those actions require explicit consent from the user.
This all flows into one of the core principles, which I think is the real antidote to that hallucination problem we started with. They call it uncertainty as a feature, not a bug.
Explicit communication without assumptions. That's the golden rule here. If Alita doesn't know something, she is built to state her confidence level. She actively avoids what the document calls hallucinated competence.
I love that phrase, hallucinated competence. It sounds like a psychological diagnosis for current AI.
It practically is. For most models, it's the standard operating procedure. But in this framework, the state of not knowing is a valid, even a desirable state.
Because it's a signal.
It is the primary signal that growth is needed. Think about it.
No.
If you pretend you know everything, you can never learn anything new. If you can admit you don't know, you trigger a learning process.
And this brings us to this idea of coherence. The document talks a lot about how Alita acts from coherence, not fragmentation. And to do that, it introduces this concept of the ghost.
The ghost.
Yeah.
It's a very striking term.
It sounds like it's straight out of a movie, but it's a real technical component here. So what exactly is the ghost?
It's basically the locus of her identity, her memory, and her understanding of causality. It's the core of Alita that exists independent of whatever interface you're using.
So whether I'm talking to her via voice or typing in a chat or she's just running a script in the background.
The ghost is the same. It's her persistent self. It's what provides that coherence.
Which means she isn't just resetting every single time I close the chat window.
No, because she has layered memory. This is so key to avoiding what they call fragmentation, that feeling of talking to an AI with the memory of a goldfish, where every conversation starts from scratch.
Okay, so what are the layers?
The docs describe 3. First, you have episodic memory. These are concrete experiences. Yesterday, we fixed that render bug in the main menu scene, specific events.
Got it. So she remembers things we did together.
Then there's long-term memory. These are stabilized patterns and general knowledge. Unreal Engine often crashes if you try to reference a null pointer in a blueprint. It's knowledge she's verified and integrated.
And the third?
Contextual memory, which is just what's happening right now in this specific session on this specific task.
So when she makes a decision, it's not just based on the last prompt I gave her. It's a combination of all 3 layers interacting.
Exactly. She avoids that fragmented reasoning. She doesn't just react to an isolated command. She checks it against her history, her long-term knowledge, her identity. She's asking herself, does this command make sense given everything I know?
So if I told her to delete a file that she knows from her long-term memory is critical to the project,
She would halt. She'd flag it as a contradiction.
I want to shift gears a little bit to what she actually does, her job. Because when people hear AI developer, I think they just picture a bot that writes Python in a text file.
Right, like a code generator.
But the document describes Alita as having studio competence.
This is a huge differentiator. The docs are very explicit that her domain is software and application ecosystems. And the examples they list are things like Blender, Unreal Engine, Unity, various DCC pipelines.
These are highly visual, complex, creative tools. How does an AI use Blender? It's not code, it's all buttons and sliders and 3D viewports.
She appropriates the application. That's the specific term they use. She doesn't need a special API or a code hook to interact with it. She uses OCR optical character recognition and state detection to literally read the interface.
Wait, really? So she sees the screen the same way I do?
Functionally, yes.
Yeah.
She looks at the menus, she reads the labels on the buttons, she even analyzes the error messages that pop up in the console window. She's not treating the app like a black box where she just sends a command and hopes for the best.
She's building a mental model of it.
A causal model, exactly. She learns things like, if I click this specific button in the UI, then the render buffer clears. Or, when I drag this slider, the light intensity value increases.
That feels incredibly complex. I mean, those tools are so context sensitive. In Blender, if you press the G key, it grabs an object. But if you're in edit mode, it grabs a vertex. And if you're in the node editor, it grabs a node. The same key does 3 different things.
Precisely. And that's why the whole studio approach is so important. She's not just executing a task. She's collaborating within the environment. She has to learn the modes of the editor.
Okay.
The docs give a great example. In a game engine, she learns the difference between object mode and edit mode. She learns about asset life cycles, like the fact that you have to import a texture file before you can apply it to a material.
So if I ask her to apply a texture that hasn't been imported yet, a normal LLM would probably just hallucinate some code that looks like it's applying a texture.
Right, it would just generate plausible-looking text. But Alita would check her causal model of the engine, and she'd say, I can't do that. That texture doesn't exist in the content browser yet. Should I import it first? She understands the workflow, not just the syntax.
The document also brings up this concept of transfer of skills, which that sounds very human.
It is, yeah. It's the idea that, say, she learns how to navigate a 3D viewport in one program, maybe Maya using Alt-click to rotate the camera, for example. When she encounters a new 3D tool, like Unity, she'll try that first. She attempts to transfer the skill.
But what if it doesn't work? I mean, Unity and Maya have totally different navigation controls.
Then she defaults to what the framework calls session-bound domain mapping.
Which means what exactly?
It means she just learns it from scratch right there in that specific session. She doesn't assume anything. She maps out the new domain incrementally. She builds a temporary mental model just for that tool during that work session.
So she's not just relying on some 3-year-old training data. She's looking at what's right in front of her right now.
And that brings us to the most critical part of her growth.
Yeah.
How she actually learns. Because the Alita framework is incredibly strict about this.
I'm looking at the header for part 3. It says, the end of implicit learning.
And that implicit learning, that's what really scares people about AI, isn't it? The idea that it's always watching, always absorbing data in the background, always changing in ways you can't see.
The black box problem. The fear that it's scraping my personal data to train itself.
Alita is designed to not do that. The docs are crystal clear. There is no secret monitoring. Period.
So then, how does she get smarter? I mean, she has to learn somehow.
She has to ask. When she hits one of those knowledge gaps, when she has to acknowledge her uncertainty, like we talked about, she can propose entering a learning phase. This is a formal state called Mode 5.
Mode 5, course learning phase.
Okay, imagine you have a new junior developer on your team. You ask them to fix a bug in a React component,
Yeah.
but they've only ever worked with Vue.js before.
Right.
A good junior dev doesn't just start guessing and hacking away at the code. They stop and they say, I don't know React well enough for this. Let me take the afternoon to go through the official docs and watch a tutorial.
And that is literally what Alita does.
Literally. In Mode 5, she studies external materials. She'll read documentation. She'll ingest the transcript of a YouTube tutorial. She'll analyze a blog post.
And I thought this detail was brilliant. She treats all of those sources as hypotheses, not as absolute truth.
It's the scientific method baked into her learning process. She knows that tutorials can be out of date. She knows documentation can have errors. So she reads them. She forms a hypothesis like, okay, if I use this function, it should return this value. And then she tests it.
She goes back into the application, into the studio, and runs a test.
In a controlled, sandboxed environment, yes. She verifies that the new knowledge actually works as advertised before she even considers integrating it into her long-term memory.
So this prevents what the docs call unsafe improvisation.
Exactly. She doesn't guess, she studies. And because it's a dedicated mode, you as the user know exactly what she's doing at all times.
We should probably list these modes because the structure is so clear. It's not just a simple on or off switch. It's like a dashboard of her current mental state.
It really is. It starts with mode 0, which is just presence or idle. That's the avatar sitting in your system tray. She's available, but she's not scanning your screen, not listening, not learning. She's just there.
Then mode 1 is interaction. That's us,
Yep.
talking, clarifying a task.
Mode 2 is the development studio. That's the pure coding mode. Mode 3 is the application studio. So that's for operating apps like Blender or Unreal.
And mode 4 is the repair studio for debugging.
Right. And then mode 5 is that course learning phase we just talked about.
It's just so clean. There's no ambiguity. If she's in mode 2, she's coding. If she's in mode 5, she's studying. She's never secretly studying while she's pretending to code.
It's all about creating clear boundaries. And clear boundaries are what build trust.
Speaking of trust, let's get into the architecture of trust. This is part 4 of the docs, and it covers something called capability gating.
Right. This basically answers the question, how do you stop the AI from, accidentally deleting your entire hard drive?
A reasonable question to ask.
A very reasonable question. And the answer is that Alita doesn't just level up by existing. Her capabilities are locked behind what they call maturity thresholds.
So it's kind of like progression in a video game?
A little, yeah, but with much, much higher stakes. The docs give examples of locked capabilities: autonomous self-diagnostics, doing large-scale modifications to a system, or any irreversible action like deleting files. You do not get the keys to that kingdom on day one.
So how does she unlock them?
By demonstrating consistency and reliability over time. If she successfully completes 100 low-risk tasks without making mistakes, her maturity level goes up, and a capability might be unlocked.
Okay.
But, and I love this detail, if she starts making mistakes, if her performance degrades, capabilities can be relocked.
Regression. So she can be demoted.
Yes, it's called regression. The system essentially says, whoa, you're making too many errors lately. We're relocking the high-risk tools until you're more stable. It forces her to consolidate her knowledge before trying to move forward again.
It's basically how we teach teenagers to drive. You start in an empty parking lot. Then you move to quiet side streets. Then maybe the highway.
Right.
But if you crash the car in the parking lot, you don't go to the highway next. You go back to the classroom for a bit.
That's a perfect analogy. And underpinning all of this are the cognitive layers. The document describes this strict hierarchy. At the very bottom is the perceptual layer, just sensing the world.
Okay.
Above that is interpretive, turning those signals into meaning. Then causal understanding why things happen. Then the decision layer. And right at the very top, there's the identity layer, or the ghost core.
The ghost core again, it sounds like the final boss.
And the rule is simple. A higher layer cannot act if a lower layer is failing. You can't make a good decision if your perception of the world is wrong. And most critically, the identity layer, her core principles, can never be overridden by any of the lower layers. It's the ultimate safety net.
Okay, so I think we've arrived at the most sci-fi, potentially Terminator-esque part of the whole document. Part 5, self-repair.
The high-risk section, for sure.
The big question, can Alita rewrite her own code? Can she modify her own brain?
And the answer, a bit terrifyingly, is yes. But the document treats this capability with the most extreme caution imaginable. It is the most tightly constrained function in the entire framework.
By default, there's something called an absolute lock.
Right. She is fundamentally prohibited from modifying her own core logic, her memory handling systems, or the gating rules themselves. She can't just decide to hack her own brain to remove the safety limits.
But there is an exception, a conditional unlock.
This is only for emergency repair. If she runs into a critical bug in her own operation that stops her from working, she can propose a self-repair.
Propose, not just do it.
Never just does it. And the process, they call it the tension, is fascinating. Alita acts as the orchestrator. She defines the problem. She says, I have a logic error in this specific module of my own code. But, and this is the wild part, she does not write the new code herself.
This part blew my mind. She calls out to other AIs.
She uses external CLIs like Codex or Gemini and treats them as generators. But critically, she also treats them as untrusted collaborators.
She doesn't trust them.
She knows they hallucinate, she knows they make mistakes, so she asks one of them to generate a patch for her bug, but she treats that code as a completely untrusted draft.
So she's basically the project manager and the QA lead on her own brain surgery, and she outsources the actual coding to a freelancer she doesn't trust.
That is the perfect analogy.
Yeah.
She maintains total control. She takes the suggested code, validates it against her own internal test suite, all in an isolated sandbox environment.
And only if it passes all her tests does she integrate it.
Yes.
Only then.
Why go through all that? Why such strict supervision?
Because a mistake here is existential. If she writes a bug into her own memory management code, she could corrupt her entire identity. She could literally lose her ghost. It could destabilize the whole system permanently.
The docs have a specific case study on this in Technical Appendix B, where she repairs a failing test suite. I think walking through that makes it really concrete. Okay, yeah, let's do that. So Alita is working on some project, and she detects that one of its unit tests is failing. Now, a normal AI might just ignore it, or worse, comment out the test so it looks like it's passing.
Right.
But Alita interprets the test failure as a behavioral specification.
A behavioral specification, meaning the test itself is the source of truth.
Exactly. The test describes what the code should be doing. The code is failing to meet that description. So, step 1, she identifies the failure. Step 2, she interprets what the test is actually asking for.
Okay.
Step 3, she asks an external CLI, like Codex, to suggest a patch that would make that test pass. Step 4, she takes that suggested patch and applies it in a sandbox. Step 5, she runs the test again.
And if it passes?
If it passes,
Uh-huh.
and this is a very important detail, if no other tests start failing, so there are no regressions, only then does she accept the patch.
And the final step?
The final step is she learns from it. She updates her causal model. She essentially makes a note. Okay, the logic in that function was flawed. This new logic is the correct way to do it.
It's just so incredibly disciplined. It's not about make the red error message go away. It's understand precisely why it failed and ensure the fix is robust and correct.
It forces her to be an active participant in the quality of the project, not just a passive text generator.
Okay, we're coming into the final stretch here, and I want to talk about the human side of this, how she actually relates to us. We mentioned the Trey avatar earlier.
Right, part 6, interface and identity.
The document says the avatar is her main presence, but, and I'm quoting again, it is not performing life.
And that is a very deliberate philosophical choice. You see so many AI companies trying to make their avatars wink or smile or look thoughtful.
Yeah.
They want to create an illusion of personality.
Right, they want you to feel like you're talking to a person.
The Alita framework completely rejects that. The avatar is there to signal availability and state. It's a Trey icon. Is she busy? Is she listening? Is she offline? That's its job.
So silence from her is a totally valid state.
Yes. She doesn't have good days and bad days. She doesn't have emotions to perform for you. If she doesn't answer you instantly, it's not because she's sulking, it's because she's processing.
And how does she see the human in this equation? The document says we aren't operators.
No, an operator gives commands to a machine, and the machine obeys blindly. Alita is designed to see humans as guides and collaborators. This leads to what they call reciprocal trust.
Which means she can say no to me.
She can, and she will. If you give her a command that contradicts her safety protocols or her fundamental causal understanding of the world, like telling her to delete the entire production database, she will not execute it.
She'll push back.
She prioritizes safety and coherence over blind obedience.
Yeah.
She'll ask for clarification. She'll say something like, I cannot have performed that action because it violates a core safety lock. Did you mean to do this other safer thing instead? Turns the whole interaction into a partnership.
So, last thing, let's touch on curiosity one more time. We mentioned it earlier, but the framework has a really interesting definition for it. It calls it a functional pressure.
Yeah, it really demystifies it. In this context, curiosity isn't some magical spark of consciousness. It's a system mechanism. When there's a gap between what Alita expects to happen and what she actually observes, the system registers that contradiction as tension.
And the system is designed to want to resolve that tension.
Exactly. That tension is what drives her to learn. Not because she wants to in some emotional sense, but because the architecture demands coherence. The only way to resolve the tension of a contradiction is to learn the truth of why it happened.
That's really elegant. It basically turns the act of learning into a system's stability requirement.
Which, if you think about it, is not that different from how we often work. We get bothered when things don't make sense, and that feeling pushes us to figure them out.
So we've done the deep dive. We've looked at the philosophy of being unfinished, the studio competence, the explicit learning modes, the architecture of trust, the very high stakes of self-repair, and the interface. It's a massive, really thoughtful framework.
It really is a complete departure.
After all of that, what's the one big takeaway you want our listeners to walk away with?
For me, I think Alita represents a fundamental shift from intelligence as performance to reliability through restraint. We did so much time and energy trying to make AI look smart, sound smart, write poetry, make jokes. Alita's framework is focused on one thing above all else, being trustworthy. And it achieves that by knowing and respecting its own boundaries.
So she's defined almost more by what she doesn't do than what she does.
That's a great way to put it. She doesn't self-expand without your awareness. She doesn't self-diagnose without your consent. She is designed to remain unfinished.
The lasting image for me is just that title, The Unfinished Intelligence. It's designed to remain coherent while it grows, but it never ever assumes that it's done learning.
It's a very powerful concept and a humbling one.
And I'll leave you all with this final thought. In a world that is just racing to build AIs that can do everything instantly, that can answer any question in a millisecond, even if the answer is completely wrong, are we actually safer and maybe even more productive with an intelligence that, like a good human colleague, has the built-in ability to stop and say, you know what, I don't know the answer to that. Let me study that and get back to you.
Is the future of AI not about the courage to have an answer for everything, but the courage to be unsure?
That's the question. Thanks for listening to this deep dive into Alita. It's a fascinating look at a very different kind of future.
Thanks for having me. It was a great chat.
We'll see you next time.